In this video, I'm going to talk about analysis question number 2 from the Carts and Masses Lab Part 2. You've got two questions here that are calculations. So it says using your data from trial 1. So be very specific, from trial 1. If the cart starts from rest and accelerates toward the end of the track 0.82 meters away, how long does it take to get to the end? So we know that we're looking for time. And I'm going to write my equations and things color-coded just so that everything is clear. So I know I'm looking for time. So what do I know? First thing is, what do I know? I know that my cart is starting from rest. That means that my VI is 0. I know that it's 0.82 meters displacement. That's how far the cart is traveling. So my D, 0.82 meters. And you're using your data from trial 1, okay? So you have an acceleration for trial 1. You're going to plug whatever your acceleration is. It is not going to be the same as mine. So my acceleration was 0.603 meters per second squared. Yours will be different. So you've got 3 givens and an unknown. What do? You're going to go back to your journal, your acceleration equations. It's on page 12. And you're going to find an equation for time that you can use, VI, D, and A. Okay, we've only got 2 options for time. This one needs a VF and a VI, so we can't use this one. We've got to use this one. Time is equal to square root of 2 times the displacement divided by acceleration. 2D over A, take the square root. So T is equal to square root of 2D over A. Now I just have to plug in my numbers. Keep your square root so that you don't forget. 2 times 0.82 meters divided by your acceleration. Yours will be different. I don't want to see anybody using my number. Again, I'm going to show you how to plug that in your calculator. Do everything under the square root first, unless you're real confident with your calculator. Everything under the square root first. 2 times 0.82 divided by 0.603. Take the square root of that, and I get 1.65, I'm going to round it, seconds. So that's my time. Second question, what is the cart's velocity at the end? Okay, at the end is our key here, so we know we're looking for VF. We've got our same givens as before. We know that VI is equal to 0 meters per second. We know that our displacement is equal to 0.82 meters. And we know that our acceleration, my acceleration, is equal to 0.603 meters per second squared. Now you can plug in the time that you got up here if you wanted to. You could use that. I always find it safer to do as many calculations using just the givens as possible. That way, in case you made a mistake in your time calculation, you're not going to then compound that mistake by using it again. So again, go back to your equations. We've got 3 options for finding final velocity. VI, A, and T, you could use that. D, T, and VI, you could use that. Both of these use that time though. I would avoid that if possible. So I'm going to use this last equation, square root of VI squared plus 2AD. I'm going to write that equation in. square root of VI squared plus 2AD. Now I know that my VI is 0, so I don't even have to worry about that. So square root of 2 times my acceleration, don't use my number, use your own number, times 0.82 meters. Okay, so 2 times 0.603 times 0.82. Remember to take your square root, and I get 0.994 meters per second. There you go. Answer the first question on your own. Only you can tell me if you think that this lab confirms Newton's second law. Once you're finished with everything, take your picture, upload it, and get your credit for today.